Hi, everybody. Welcome to section 5.1, anti-differentiation and the indefinite integral. So the learning objectives for this section are to find the general antiderivative of a given function, find the indefinite integral of a function, and solve initial value problems of functions and applied problems. So let's look at the definition of the antiderivative. So the antiderivative or integral, so suppose that capital F of x and f of x are two functions such that f of x is the derivative of capital F of x. That is, the derivative of capital F of x equals little f of x. Then capital F of x is an antiderivative or integral of little f of x. So in other words, an antiderivative undoes the operation of taking the derivative. So we're going in the backwards direction. So let's look at an example. So consider the function f of x equals x squared, and we want to find the antiderivative of this function. So notice that if I take the derivative of x cubed over 3, I get 3x squared over 3, and then the 3's cancel out, and I'm left with x squared. So that's what I'm desiring. So capital F of x equals x cubed over 3. So f of x equals x cubed over 3 is the antiderivative of f of x equals x squared. But it could also be something along the lines of f of x equals x cubed over 3. But what if we had plus 1 or x cubed over 3 plus 100? The derivative of all of these functions, x cubed over 3 plus 1, x cubed over 3 plus 100, the derivative of each one of these functions will also be x cubed because a constant just goes away. So here's what we got. We line into the idea of a constant when we integrate. So what we leading us into is the indefinite integral. So we need to account for the possibility of a constant. So here's a definition of an indefinite integral. So the indefinite integral, suppose that f of x, capital F of x, is any one of the infinitely many members of the family of antiderivatives of f of x. So that means the integral of f of x is going to be your antiderivative plus c, that constant. Much like we did in the example above, we would need a constant here because it could be any one of these constants, 100 or 1, negative 1,000, etc. So we need to account for a constant. Let's keep reading. So c is an arbitrary constant. The function capital F of x plus c is called the antiderivative or indefinite integral of f of x. The number c is called the constant of integration. The function f of x is called the integrand, and dx is called the differential. Okay, let's go ahead and look through some integral formulas and properties. So much like with taking derivatives, the constant just comes along with you. So if we have a constant attached, we can just take the constant out of the integral. The integral of two functions will just be the sum of those integrals separately. Same thing for subtraction. We can separate out the subtraction. And let's go ahead and look at these right here where we need to fill out. So here for number 4, we have the integral of k dx. So here k is just a number. So if we have k, if we're taking the integral of just a number, all we're going to do is just add on an x. So what I mean by that is the integral of k dx would just become kx plus c. So say just add on a x. Okay, for number 5, we have x to the n dx. So this is just any power. If you raise to any power, it could be x squared, x cubed. And this is our opposite of that power rule when we take a derivative. So when we have something, an integral as x to the n dx, the integral of this would be x to the n plus 1 over n plus 1. So it's the opposite of that power rule when we take a derivative. So what I'll say here is add 1 to the power, divide by same value. So you just add 1 to the exponent and then divide it by that n plus 1. Okay, so number 6, e to the x, the derivative of e to the x, much like, I'm sorry, not the derivative, the integral of e to the x, much like the derivative of e to the x, is just going to be itself. Much like with a derivative. It's just a continuous loop with exponential x. Okay, so let's keep looking at number 7. The integral of 1 over x dx. Well, if you recall that the derivative of natural log of x equals 1 over x. So we're just going in the backwards direction. So the integral of 1 over x just becomes natural log of x. But here's a catch. It's going to be absolute value of x. Natural log of absolute value of x. But okay, so that's it for this introduction. The next video, we're going to go over some examples, but I'll see you next time. Thank you. Bye.